Hello students, welcome to the video. So this is the part 3 for the previous year questions of chapter 1 of class 10th, right? So this will be the last video of this chapter, that is real numbers. So without wasting time, let's start with the question. So first question is, three sets of science, history and drawing books have to be stacked in such a way that all the books are stored topic wise and the height of each stack is the same. So the number of science books is 192, the number of history books are 480 and the number of drawing books are 672. You have to determine the stacks of science, history and drawing books. So what we have to do in this question, we will find out the HCF of the given numbers of the three books, that is 192, 480 and 672. So for finding out the HCF, we will do the prime factorization of each number. So prime factorization of 192 will be 2 raised to the power 6 into 3. Okay. Prime factorization of 480 is 2 raised to the power 5 into 3 into 5. Okay. And prime factorization of 672 is 2 raised to the power 5 into 3 and into 7. So HCF is basically the highest common factor. So we will check that which number is the common between these three values. So HCF of these three numbers will be 2 raised to the power 5 into 3. So it will give you 96. That means there must be 96 books in each stack. Okay. So now we will find out the number of stacks for science book. Okay. So total number of books are 192. We will divide it by 96 and we will get 2. So there will be 2 stacks of science books. Okay. Similarly, number of stacks for history book. Total number of books are 480. Again, we will divide it by 96 and we will get the answer, that is 5. Then number of stacks for drawing books, that should be equal to 672 divided by 96, so it will give you 7. Okay, so stacks for drawing books are 7 and number of stacks of history books are 5 and number of stacks of science books are 2. Okay, so now let's move to the next question. So next question is show that 5 plus 2 root 7 is an irrational number where root 7 is given to be an irrational number. Okay, so first step will be, we will let that 5 plus 2 root 7 is equal to your rational number. So let's say it is a by b and a and b are co-prime numbers. Okay, now we will simplify this equation. Okay, so now we will transpose 5 from LHS to the RHS. So we will get 2 root 7 is equal to a by b minus 5, right? Now we will take the LCM on the RHS side. We will get 2 root 7 is equal to a minus 5b divided by b. Now see, in on the LHS side, 2 is multiplying with root 7, so we will divide it on the RHS side. We will get root 7 is equal to a minus 5b by 2b. Now see, this is your LHS part and this is your RHS part, correct? It is already given that root 7 is irrational, right? And we are getting that root 7 is equals to a minus 5b divided by 2b, correct? And this is your rational number. This is your rational number. So LHS must be equal to RHS, correct? That means if root 7 is irrational, hence this should be irrational as well. But it contradicts our assumption. Therefore, 5 plus 2 root 7 is an irrational number. Okay, got it? Now let's move to the next question. Question is, given that root 5 is irrational, prove that 2 root 5 minus 3 is an irrational number. Similarly, we will apply the same steps. Okay, so let's say 2 root 5 minus 3 is equal to a by b. Okay, and a and b are co-prime number. Now we will simplify it. So we will get 2 root 5 is equal to a by b plus 3, right? Now we will take the LCM. So 2 root 5 is equals to a plus 3b divided by b. right? Now we will transpose 2 from LHS to RHS side. We will get root 5 is equal to a plus 3b divided by 2b. Got it? Now, see, it is already given in the question that root 5 is irrational number, right? But on the RHS side, we are getting rational number. That means it contradicts our assumption, and hence 2 root 5 minus 3 is an irrational number. Okay. See, there are many previous year questions based on this topic. Okay, so I guess now you can easily solve it. Similarly, that means 2 minus root 3. You have to prove that this number is irrational. So you have to apply the same steps. Okay, and now let's move. Okay, one more question is here, that is 2 plus 5 root 3. Prove that this number is also your irrational number. So you will again apply the same step. Okay, now let's move to the next question. What is the greatest possible speed at which a girl can walk 95 meter and 171 meter in exact number of minutes? Okay, so as the girl needs to walk 95 meter and 171 meter at the exact number of minutes, so we have to find out the HCF of 95 and 171, right? So we will find out the HCF of 95 and 171. So for finding out the HCF, the first step is to do the prime factorization of the given number. So prime factorization of 95 is 5 into 19, and prime factorization of 171 is 3 into 3 into 19. Now HCF of 95 and 171 is equal to the common number, right? That is 19. Okay, hence the greatest possible speed is 19 meter minute per minute. I hope this question is clear to everyone, right? Now let's move to the next question. तेरे पास ही तो है, नीचे ही रखा है. Okay, so question is, three alarm clocks ring the alarms at regular intervals of 20 minutes, 25 minutes, and 30 minutes respectively. If they first beep together at 12 noon, at what time will they beep again for the first time? So here we will find out the LCM. Okay, the time when they ring together is equal to LCM of 20, 25, and 30. Okay, so now we will the first step for solving this question is to do the prime factorization of 20, 25, and 30. So prime factorization of 20 is 2 into 2 into 5, and prime factorization of 25 is 5 into 5, and prime factorization of 30 is 2 into 3 into 5. Now LCM will be 2 into 2 and into 3 into 5 into 5, right? Here we are getting 5 as common, right? And 1 2, one pair of 2, and then single 2, single 5, and single 3. So here is the LCM. So LCM will be 300, right? So 3 bells ring together after 300 minutes, or you can say 5 hours. How 5 hours? If you divide 300 by 60, you will get 5 hours. Okay, so since they rang together at 12 noon, so they will ring together again at 5 p.m. That means you will count after 12. 5 hours, you will count 5 hours after 12, so you will get 5 p.m. Okay, so again these 3 bell will beep together at 5 p.m. Now let's move to the next question. So question is, the greatest number which one divides 1251, 9377 and 15628, leaves remainder 1, 2 and 3 respectively is. So this is basically one marker question, right? So what we will do in this, first of all, we will subtract the extra value from the given numbers, right? So we will get 1251 minus 1, that is 1250. Okay, now again 9377 minus 2, we will get 9375. Next 15628 minus 3, we will get 15625. Okay, now we have to find out the greatest number which one divides this leaves remainder. So what we will do, we will find out the HCF of these three numbers. So first step is to find out the prime factorization. So prime factorization of 1250 is equal to 2 into 5 raised to the power 4, and prime factorization of 9375 is 3 is into 5 raised to the power 5. Okay, and prime factorization of 15628, that should be 5 into, okay wait, 5 raised to the power 6. So HCF will be 5 raised to the power 4, and we will get 625. So this number, when this number divides the given three numbers, so it leaves the remainder 1, 2 and 3. Okay, now let's move to the next question. Question is, if n is a natural number, then 2 into 5 raised to the power n plus 6 raised to the power n always ends with. This is again one marker question. Okay, so now what we will do in this, we will let us that take an example of different powers of 5. Okay, so as 5 raised to the power 1 will give you 5, right? 5 raised to the power 2 will give you 25. 5 raised to the power 3 will give you 1 to 125. So what you are seeing, that the unit digit are always 5. Unit digits are always 5 whenever you are putting any power on 5, right? So that means unit place of 5 raised to the power n will be 5 itself, right? Now if we put the n is equal to 1 2 3 so on n is 6 raised to the power n, so we will get 6 raised to the power 1, that is 6, and 6 raised to the power 2, that is 36. So again we will observe that the unit digit of 6 raised to the power n is always 6. Okay, so now we will add this. So 2, see, unit place of this is 5, right? Unit place of 6 is raised to the power n is 6. Now if you add it, you will get 11. Now multiply it by 2, you will get 22. You will get 22. Now see, unit digit of this number will always be 2. Will always be 2. So 2 is the answer. So okay, so we have covered all types of questions of chapter 1. Okay, we have covered all types of questions of chapter 1. Now please go through all the videos for your revision part. Now in the next video we will start with our chapter 2. Okay, so okay, have a good day. Bye bye.